across industries. To explore this exciting investment, we now move to our next session titled Beyond Buttons, the Evolution of Intuitive Human-Robot Collaboration. In this session, we will explore the current and the future trend shaping human-robot collaboration, the different phases and levels of interaction between humans and robots, key collaboration concepts, and the challenges involved in implementing them, the concept of collaborative robots or cobots, and how they work alongside humans, the idea of active personal space or work envelope in ensuring safe and efficient collaboration. By the end of this session, participants will gain a clear understanding of how human-robot collaboration is evolving and how these innovations are paving the way for more intuitive and intelligent interaction between humans and machines. We are honored to have with us our respected session chair, Mr. Rahul Chowdhury, sir, Assistant Professor, Department of Electrical and Electronics Engineering, Primary University, Chattogram. Sir, we are truly grateful for your present guidance and continuous support. It is now my great honor to introduce our distinguished speaker, a professor in the Department of Mechanical Engineering and Director of the Directorate of Research, NextGen DRE at CUET. He specialized in robotics, mechatronics, and Industry 4.0. He completed his studies at CUET, followed by an MSc in mechatronics from Technical University of Hamburg, Germany, and a PhD in robotics and artificial intelligence from Saga University, Japan. His global exposure includes participation in NASA's Lunabotics mining competition and international robotics events such as ABU Robocon. With extensive academic and research experience, he has published over 115 papers in renowned platforms including IEEE, Scopus, and Springer, and has actively contributed to international research and innovation initiatives. So please join me in warmly welcoming Dr. Sajal Banik, sir.
Thank you. I at first want to congratulate IEEE Student Branch Primary University for the nice initiative for taking this such kind of webinar, and which is very important for our future generation who are interested to work with the robotics and interaction. So at first, I would like to, if you are to allow me, maybe I am allowed. Can you hear me? Okay, now I am sharing my presentation.
শুভ নববর্ষ সবাইকে। সদস্য আসসালামু আলাইকুম।
ওয়ালাইকুম আসসালাম।
স্যার দেখতেছি আমরা, আপনি স্লাইডটা অন করলেই হবে এখন। হ্যাঁ,
ওকে। Can you see now?
Yes, sir. Yes, sir.
Wait.
স্যার স্টপ।
Okay.
এখন ঠিক আছে।
Okay, now it's fine, I hope. So I'm going to start my presentation and hopefully all of you can hear me. So today's presentation is Beyond Buttons, the evolution of intuitive human-robot collaboration. So before going to my total presentation, I am just giving you the brief outline that why buttons are going to be obsolete very soon. That will be discussed very fast. And present trend of robotics and what is going on the robot market. Actually, the interaction depends on the type of uses also. So what kind of interaction should I do with the robots? It depends on also the uh, use objective. So wait a bit, whether I can take a pen, laser pointer for you. Okay. So later on, I will discuss about the latest format of robot that which will directly work with the human, or like a worker, co-worker, I can say that, which is called cobot. And here we need to think about very seriously how I can continuously interact with my cobot. Actually, this all the knowledge depends on mechatronics and robotics knowledge profile of every applicant who is going to work on this issue. Next, challenges, opportunities, and conclusion will be discussed. Next, I am going to not working. Okay. Okay. Maybe there is a one kind of video. Okay. Now it's okay. Please tell me.
Yes, sir. It's
Okay.
visible.
Okay. Human robot interaction methods. All of us, we know that there are basically five methods that we directly communicate. One is we call verbal or non-verbal, or using GUI, graphical user interface, with the robot. Then physical contact, like your button switch or maybe remote control. Then autonomous level, with that manual communication or autonomous communication. Then technology used, that we can communicate with the robots by using the sensory output or brain signal directly, like EMG signal from our brain. All, and also that we call that you target is spontaneous communication. This is collaboration type, which is cooperative or social type of robots we need. And all these things are performed with such kind of communication channel. We call it GUI kinesthetic, which is called that physical guidance, or touching the any button or any devices, such that the robot can communicate with you. And maybe IoT devices or remote control, speech and gesture and posture can be read by the robot. Cognitive social signals and multimodal. Maybe some of the channels are directly using in same robot. This may be also happen. Okay. So why beyond buttons? Actually, the button control, maybe we can say that around 50 or more years, that very basic for interaction with the robot. And if you see the buttons, buttons are maybe we can say the discrete, that one command at a time, and explicit type that you must push them, and one way. Robot does not interact. You can only command by the buttons. So what is the real scenario? Scenario is that robot also need to share its space, time, task related information with the humans. And for this kind of reality, buttons are nowadays the bottlenecks for flawless communication, for collaboration purpose. For example, maybe the video will not work here. Oh. So it is actually Munna, Professor Munna, are you here? Hello? Hello?
Sir, Munna sir is not available right now.
Okay.
Rahul sir is here.
Okay. So video is not working. Maybe I have to stop here again, run the video again. In Google Meet, actually, there is a problem.
Sir, is there any play button in the video, in the presentation?
No, actually, I have loaded it, and during my complete here I have done, but now it is not working. Okay. I think it is a robot that by which you can order your robot for omelette or whatever you want, single button for each item. So you see there's very limited cooperation. Okay, so here you see, okay, it is running. Can you see?
Yes, sir.
Yes, sir.
Okay, you see that one person has ordered one omelette, and robot is making the omelette according to that button instruction only. So you cannot modify anything. The amount of onion, amount of chili, nothing. So I think you have enjoyed it, that only single button communication, one omelette is serving and making by the robot. So you cannot change anymore. So by the robot, when you are going to establish a communication profile, then most importantly, you have to understand what are you going to do, or what kind of performance do you want from this robot. So you know that nowadays robots are being used in several sectors like manufacturing, sensing, port, agriculture, consumer, logistics, automation, security, surveillance, healthcare, etc. And everywhere nowadays robots is performing very well and with high reliability. That is very important. So to establish a good communication with the user of the robot, we need to establish a very automated and enthusiastic and cognitive type communication that a robot can understand or can read your mind also in that level. So next, you see that why communication is very important, human-robot interaction, because you know that human being is very much flexible in any situation and he can take the decision in any situation properly, but physical work and limited productivity, due to this, only human being cannot accelerate a company or industry properly. So, but if you think about the industrial robot, that it has high productivity but limited flexibility. So, next issue is that if you want a good high level flexibility and high productivity in a company, that you need to establish a human centered robotic system. So in that case, you will get the most benefit from flexibility issue and productivity issue. So in that case, next issue is arising, then what kind of communication will be needed for this kind of human-centric working environment? So in that case, you see that robot is working with the human being. So if you classify the interaction level, we can classify in three groups: coexistence, cooperation, and collaboration. So coexistence means that robot and human working the same industry, but robot and human does different operations, even in different place. And human cannot, maybe the robots is separated by fencing, and it is working in its own way, only sometimes monitoring. So coexistence side, communication is very core level communication is needed. Cooperation means robot and human does the same job. So robot is made to do the job by simple commands. So here you see that the communication level is increasing. The most importantly is collaborative type robots, that very advanced level of robot. Here you need a very present level, next level of human interaction. And as the robot will work with the human, we like a co-worker in the same place and same vicinity, very close. So here I can again show very one sort of video that you can see that how a human and robot can work collaboratively and what kind of communication level is necessary here. You see here collaborative assembly of engine block. So there are 4 cameras are using for monitoring. And you see the screw placement is very tough for robot. So this task is performed by human being. Only tightening the screw is performed by robot. And you see that here the the worker and robot is working very closely. So now I want to just shortly bring you the three scenario of robot human robot interaction. Very old days from 2000, you will see that human robot collaboration was very premier level, and at that time robots was working safely with a cage or fencing system. So the user of the robot was working with either physical learning, this is called uh, uh, hand motion. Hand motion, by using the hand motion, the robot is learning how we can move from here to here. So by using the hand motion, the programmer is teaching the robot that how it can move the paper from here to suppose on the table. So you see that here programming is done by the head motion. Another way for programming is using the teach pendant. It is called teach pendant. So this user is interacting with the robot by using like a tab, which is called teach pendant. And in that kind of premier level communication, actually no real-time sensing of humans, and only you see that sequence is going from human to robot, never together. So which is very important that robot also need to communicate with human continuously for proper collaboration. That is the drawbacks of the previous kind of interaction. Next is you see the shipment to next level, that with the previous hand guiding, also some proximity sensor or proximity devices informations are coming to the user. So this is the next level of premier level that I saw you the previous slide. Here actually with the button integration, there are some monitoring phenomena that we can monitor the robot, that how much work is done, and you can program the robot by hand guiding, and also so there are some limitation, force limitation, position limitation mechanism. So in that way, you can make the communication better than previous type of communication. The present scenario is very much different. That it is we call that intention-based interaction. That means in the current scenario, robots are very much collaborative and very high reliability that robot has. And human beings are thinking that robots are a co-worker. So, like a co-worker, the robot need to communicate with the user or the robots such that a human being interact in the same way almost. You see that a robot can understand the human eye direction, that is gaze recognition. Then another is robots interpret body languages. But actually, robot can understand the body language postures analysis. It can perform. Also, robots can understand the hand movement. That by using the head movement, you can also control the robot. This is called gesture control. And most importantly is natural language, NLP, natural language processing. Robot can understand the voice command. Next issue, even robot will not wait for your command or your movement or any kind of instruction. So it will take the predictive movement. So here robots are very much intelligent and AI incorporated very strongly that it can decide what to do in the next step. So another is seamless collaboration that you have already seen the video of working with the same, that is robots work and settlement without any button. So as a worker, like a lively worker, like a human being, it is also working with you. So in that case, next issue that how the robots can seamlessly communicate with you and understand you. That means communicate means the robot can understand it. So by using the previous communication channel that I explained in the slide number 3, that it is using several kinds of sensing devices and also multimodal large level language understanding with some kind of sensor, physiological sensor, vision system. You see there are basic sensing devices also by which a robot can see and understand you. So this is the basic phenomena for current level of communication. So here I am using another issue that actually in which how much level robot can work with you in that I'm calling you a co-worker. So you see that robots need to be work like a co-worker here in this figure. So it is very important that always there should be understanding between the robot and human being. So how we can do it? Because as I am telling you new term, collaborative robot, now the industrialists have already motivated that even industrial robot has the high cost, but collaborative robot is saving around 27% for installation for the same procedure. So nowadays, people are highly motivated to use the collaborative robot in case of industrial uses also. So you think that why? Because robots collaboration is very much human-like and the interaction level and performance of this kind of robots are day by day progressively very fast and real-time scenario communication is performed. So that is why nowadays industrial is also very much motivated to use the cobots in their company. So cobots and robots, if you see in the net also, you will say that there are some differences. So industrial robots are very fast and it will not think about so much about the safety of people. If somebody is entering into the periphery or which we call the working envelope. Working envelope means the industrial robot maximum in 3D point, 3 dimension, how much it can reach in a scenario. That means how much it can reach in the 3D space, which we call it work envelope. So if somebody is wrongly entered into the work envelope, he definitely will be in danger. And because industrial robots are very much speedy, but robots speed actually how much? Robots arm actually mimic the speed of human arm. That means our arm, how this arm work in a table or in a other issue, Samely, cobots will also work in the same speed of human being or even lower than the human being arm. For example, if you can see the Roke is a Rethink Robotics company that invented this kind of robots. For this kind of robots, actually, we call it cobots, because they're using the robots with the human being in a collaborative way, not the replacement of human being. But here, industrial robot replace the worker, and it was the same work of the worker. So you see, for example, Baxter. Baxter is also an industrial robot. Uh, Next is, this is actually not important for you, that it is a statistical data, but same attitude has been shown in 2020, that the uses of collaborative robot is increasing with respect to industrial robot. Here you can see that in that statistical data, 23% worldwide robots installation is increased, where 5% only traditional industrial robot. Same until 2020, I have seen in the internet also. So robots are being highly occupying the industrial places, but it is not easy issue to employ the robots in every sector, because there are some limitation, like the robot, that because it is low speedy, and at the speed of the collaborative robot is lower and almost like the human arm. So you see that if you design the previous layout of the company with high-speed industrial robot, now you are going to replace the same robot with collaborative robots. So there are some issues like speed management, feeding, safety should be configurable of the total layout of the industry, and product design, and tax allocation issue. This is the new issue will be arises for the employment of cobots in your industry. And you see that so many investment arises when you are going to cobot also in the industry, but uh, the benefit level is high with respect to other issue. That is why companies are nowadays using the cobots in their company. And cobots, actually, the uses of cobots has been tremendously increased after the pandemic situation, the COVID. So in that time, cobots have tremendously used for testing the cobot, even health worker, doctors, disinfection the areas, even identifying the areas, making the PPs and other safety tools to handle the dead bodies. For all the issues, actually, cobots has done, not industrial robot. So you see that for pandemic situation and any kinds of emergency situation also, cobots will play the great role. So you see some figures that spraying, that disinfecting, collecting the sample from one person, making hospital beds with the cobots, disinfecting by using ultraviolet ray or the computer table. So many issues apart from during the cobots issue. So you see that this usual situation in an industry like ready-made garments and other industries, all the peoples are working. But when you see that we need to transform, or we need to replace some peoples, so this kind of situation will be arises. And previously, two person, in what level they were used to communicate with this person and this person for maintaining the same performance in the process. So these two robots will need the same level of communication with this same two person. So this is called flawless communication. So this kind of flawless communication is the now present issue. And there are so many technology nowadays to perform this communication on time and without any delay. Otherwise, this production will be hampered. Actually, in industry, the robots are replacing by robot, and there are so many issues that risk analysis, programming, efficiency, worker acceptance, expectation about robots fulfill. There are so many researches on that. Why people are agreeing to using the robots. So you see that the agree percentage most of the cases is higher, but there are some lower issue also. Agree percentage is higher, you see. And main barriers is the adoption of robots is that knowledge gap. You see, the lack of knowledge, people are not, even still now, people are not motivated to work with the robots. So main issue is lack of knowledge issue and worker acceptance also. And somebody still thinking about the robot safety. So robot safety actually it is not so many so important issue because it is low velocity robot. So it is not normally done not dangerous with the users. So here another uh, data is that the requirement for human robot collaboration. That means why and which level of collaboration is interaction with the robot is necessary. Why necessary? Because of safety, flexibility, efficiency, and usability. So if any collaboration gap is maintained between human and robot, each one will think that another one is useless to me because either human will think robot is useless and robot will think nobody is there. So we need a good communication. So challenges actually robotics is mainly with the nowadays you see well-established robot manufacturers are there and others people are not thinking about this. So all of them are user only who are using. And some of the students of in Bangladesh also, they are working with the robotics, maybe hobby. Some of they like to work with these robotics and want to see what is going there. And even our engineering discipline does not concentrate on the robotics and their communication and etc. Very few universities are working with mechatronics and robotics. And most of the cases actually I have seen, our students are suffering with the robotics research is that they always show that we are lacking some simulation software which is very expensive and standard. So another issue is that robot designer and robotics system integrator, if we want to find a good trainer, we will not find still now. Maybe some of the have already developed, but still far to go in our country. Another thing is that robotics actually multidisciplinary topics. So huge knowledge of mathematics, science, mechanical, electrical, computer science, everything is there. So people's and our students are generally afraid of robotics. And what they do, they actually make a robot and try it, and if not work, they destroy it. Some like this, but this is not the way of robotics. At first, you should select the task, then you should design the robot, then you will run the simulation. If the simulation is good, then you go for a prototype and test the prototype, and then again redesign if it is not working. So this is the way. And another thing is that whatever we are going to establish a very good robotics society, and we want to develop the knowledge about human-robot interaction. What is the drawbacks is that we very much concentrated on our knowledge mainly, remember understanding, which is called Bloom's taxonomy. But if we really want to work with robotics, we need to reverse the situation, and we need to spend more time on analyzing, evaluating, and creating. That means what I'm going to say you that if you want to work with the robotics and their interaction, you need to spend time on applied research, not on the book only. Then engineering back knowledge you need also, and technology invention. So this is the way we can play a great role in robotics and robotics society and modern human-robot interaction development. So whoever are working with the robotics, I think that you have already know that robots have a very wide future in Bangladesh also. And actually, still now, ROS expert are lag behind, so we can also work with this one. And what you see that nowadays you can design and make any complex structure by using 3D printing technology, which was not previously in our Bangladesh. So nowadays students are also very expert in 3D printing, so they can make the structure, and we are in a very good situation in sensory and power electronics knowledge. So nowadays we are gradually overcoming the issues, and maybe some of you can be entrepreneurs of robotics. So I'm going to conclusion. So future workforce, we have seen in the one research paper that we are the future workforce are ready to work with the robot in the industry, offices, and other users also, even in service and other users. And we need to think about that Industrial 4 and Industrial 5, the role of robotics and cobots. And in that way, we think we need to develop ourselves. And we should take care about the other countries, that what are they doing about the cobots and robots. And in that way, we should also how we can play a role in the industries. This is our goal. And if you see that gradually every day market volume robots is increasing, not in decline mode, because previously it was thought that robots is a job killer like this. So robots will destroy our job. So this concept is already gone out. So it is very old thinking. Nowadays, people are working with the robots. And if you see the market in robots, Asia Pacific region is big marketplace for robots. So what we can do, and also I have done a research about what is the perspective of Bangladesh. In that case, I have seen that there are good perspectives in toy and pet robot and service robots in our country also, because industrial application is actually another issue, but this is another most important issue in our country. Such kind of robots has a good demand. And all of you know that AI is playing an important role in every sector, and also robotics is not exempt from this issue. So please also have the target about the using of AI in robotics, and it is very necessary in our country also in future. So I think finally, never regret robotics and never have a fear on robotics, that it is very complex or it is multidisciplinary issue. So please design robot, make robot, and employ the robot wherever you have the scope and you have the scope of employment of your knowledge. I think I have finished, and these are the references that I have used. And now I welcome any kinds of question or discussion, whatever you like. Thank you very much.
Thank you very much, sir. Thank you for your wonderful session. We truly appreciate your valuable insight. It has given us a clearer understanding of the topic. So with your permission, we would now like to proceed to the Q&A session.
Okay. So I should stop sharing, yeah?
Yeah, yes. Guys, you have any question, please send us in this chat box. We will, our session speaker, answer your all kind of questions. So here is our first question, that how do technologies like AI and machine learning improve human-robot collaboration?
Yes, very good question. Actually, what happened that if you incorporate the AI model, artificial intelligence model of you thinking, that how you think and what you should do with the robots, if this kind of thinking or model incorporate in the robot, then what will happen? You see that the communication frequency will be decreases, because time to time robot will not need to communicate with you. And for your kind information, that I have also worked with the emotional communication between robots. In that case, also I've seen that if you communicate with the robot with cognitive level, then the normal communication frequency will be more. So in that case, you will not your time and your communication cost will be reduced also.
Thank you, sir. Our next question is, what are the major limitations of current human-robot collaboration systems?
Oh, that is main limitation is that I can say that communication speed, how to make it very real time, and the next issue is that communicated data volume, that how much communication volume data you are transferring, and data structuring. This kind of issue is still complex. So I think these are the main issues related to communication performance. And main issue is that speed level, network speed, and also sensory performance, this kind of issue.
Okay, sir. Then our next question is, can industrial robot replace the industrial automation?
Can
industrial
industrial
robot
robot
replace the industrial automation?
industrial automation? Industrial automation, actually, the application of robot is one component of industrial automation. So there are other issues also to make a company in automation. So robot is one of the accelerating function that will make a company or industry to reach at the automation level.
Okay, sir. There is another question. In human-robot interaction, how does the concept of personal space change when a robot is no longer a static machine but an intuitive collaborator that needs to be physically close to the user?
I understand the question. Actually, very good question. We call it whenever you see, whenever physically two person communicate, we and talk, suddenly two person make a safe distance that they comfortably communicate with each other by maintaining a safe distance. So active personal space is a same issue that whenever a robot is being used in a human-centered environment, like there are some the other robot, there are some human nearby him, then we need to define the active personal space of the robot, that surrounding there are some moving parts like other moving robots. So the active personal space depends on the relative velocity between the two interactive robot. At first, relative velocity and types of the task and structure of the robot. These three will define the active personal space between two interactive robots in the industry.
Thank you, sir. Our last question is, how do robots differ from the traditional industrial robots in terms of flexibility and usability?
Okay, flexibility and usability. Flexibility, robots are more flexible, and also usability is also more than the industrial robot. Normally, industrial robots are designed for a specific task, and with a high velocity, high productivity, he will perform the task very speedy. And the diversity of the tasks is limited for the case of industrial robot. But robot structure is like that. If you just change the gripper or the end effector or arm, the same robot can perform multiple tasks in the same line, and it has so much flexibility in selection of tasks and environmental structure also.
Okay, thank you very much, sir, for your time. Now I will move on to the short quiz session. I will ask our technical team to proceed for this quiz session. And please, all of us, participate actively.
Hello, everyone. Am I audible?
Yeah, you're audible.
Okay. I'm Iftikhar and I'm from the technical team. I hope you all enjoyed the insightful session on the human-robot collaboration. So, sir has shared so many different aspects of it. So I hope you all enjoyed it and will be able to answer those things in quiz. So I have shared the link in the chat box. Kindly everyone join. So far, 6 participants has joined. So we'll be waiting for a short period so that others can also join. Kindly join using your full name so that we can identify you for ranking in the quiz session. We'll wait 2 more minutes, then we'll start the quiz session. By then, kindly join everyone. So far we have 19 participants. I hope you all have joined. We are going to begin the quiz session shortly. All right, we may begin now. So I'm starting the quiz now. Everyone prepare yourself. So our first question, what does the term cobot stand for? Your options are combined bot, cognitive bot, collaborative bot, and control bot. I can see 11% has answered. You have 10 seconds. 5, 4, 3, 2, 1. So let's see. This is the rank. Okay. In first position, we have Sudipta Das. Then second, Abhishek Borua. Third is Rajesh Malik, and so on. Let's see. Next. So 12 people have got correct answers, 4 got incorrect, and 4 did not attempt. So I would suggest those who did not attempt to attempt, try to attempt. Moving on to the next question. Cobots arms are designed to mimic the range of motion of a what? Your options are any device, human arm, machine, or network. You have 5 seconds. 4, 3, 2, 1. Let's see. Now there is a little bit change in the second and third position in the leaderboard. The first position remains to Sudipta Das. Second is Amit Chaudhary. Third is Abhishek Barua. Okay. 59% of the participants have got the correct answer. Moving on to the next question. A cobot is an apparatus for interaction between dash and dash. So what are the answers? It can be a person and computer, a device and computer, a device and device, a person and person. Let's see. We have 15 seconds remaining. Hurry up. The faster you enter the answer, the more points you get. That will be defining your ranking in the final positions. Let's see. Now the ranking. Oh, the ranking has changed. So Abhishek Bora is currently in first position. Second, Mr. Sajid Sultan, MD Sajid Sultan, then Sudipta Das, who was leading. Okay. Let's see. Moving on to the next question. Baxter is which type of robot? Humanoid robot, industrial robot, a social robot, or a lab robot? We have 20 seconds remaining. 10 seconds. 5, 4, 3, 2, 1. Let's see now. Is there any change? Yes. Sudipta Das has taken over the lead again back, but the first and the second are level on score. And third is Abhishek Barua, and fourth is Shriyantide, fifth is Anekdas Priyam. So let's see if there is any changes in the next part. So far, 68% of the participants got correct answer. So only 4 incorrect and 4 did not attempt. So I would recommend everyone, those who are not attempting, to try, because you might never know when you can rise up the rankings. So Dash allows a programmer to teach robot paths and positions. What is it? Monitored stop, speed and separation monitoring, power and force limiting, and guiding. 15 seconds left. 10. 5, 4, 3, 2, 1. Time's up. Let's see. The ranking has slightly changed in the second and third position. Moving on. Oh, this time only 26% of the participants got correct answer. Only 6 correct. And 10 people got incorrect answers. Answer carefully but fast. Moving on to the next question. The study of robot motion without regard to forces is known as robot kinematics, robot dynamics, robot geometrics, robot statistics. Ten seconds to go. 5, 4, 3, 2, 1. Time's up. Let's see how many of you got the correct answers and is there any change? Yes, there is a change in leaderboard. Onika's Priyam is in the top position, and then in third position, Protoy KD has risen up. Okay, moving on to the next question. What is the name of the space inside which a robot unit operates? A dead zone, an environment, exclusive zone, work envelope. Let's see. 10 seconds remain. Time's up. Let's see how many of you got correct answers and is there any change? Yes, there is a change. Asif bin Muqtadir has risen up in fourth position. Philip Das is coming back, trying. And in the top 3 positions, it is as before, slight changes. A few number of students got correct this time. Let's see. We are in our going to our 8th question. Which of the following is a common safety feature found in cobots? High voltage shield, power and force limiting sensors, large physical barricades, fire detection system. 20 seconds to go. 10, 5, 4, 3, 2, 1. Let's see. The top three, 4 position hasn't changed. Let's go to the points. 11 people of you got correct. That's good. So we are going to our second last question. Which sensor is commonly used in cobots to detect human presence? A temperature sensor, a proximity sensor, a pressure sensor, or none of these? This might be a trick question. Answer carefully. 15 seconds to go. 3, 2, 1. Time's up. Let's see. In the ranking, the top positions are the same. There is a slight gaining up in the between. Only 39% of you got correct. Okay. So try to answer. This is the final question. So everyone, good luck. Let's see how the table changes. Which of the following terms refer to the use of compressed gases to power the robot devices? Pneumatic, piezoelectric, hydraulic photosensitive. 15 seconds remain. 5, 4, 3, 2, 1. Now let's see our top rankings. So in third position, we have the second runner-up, Sharmin Day. I would like you all to give them a virtual congratulations. In second position, the first runner-up, we have Protoy KD with 7,580 points. And our champion of the quiz session, Onikdas Priyom, who scored 8,360 points. Congratulations to all of you. So the quiz winners, the top three, I would like you all to write your full names in the chat box. Kindly write your full names in the chat box so it will be easy to navigate the winners later on. So a big thank you to everyone for participating in the quiz, and I would like to congratulate the winners again, once again. So keep exploring, keep innovating, and stay curious about the future of humanoid robots collaboration. So now I would like to pass the session back to our wonderful host. Over to you.
Thank you very much, our technical team, and thank you everyone for your participation. Now, again, I would like to remind you all to kindly fill up the attendance form provided in the chat box to receive your session certificates. So now I would like to invite our respected session chair, Mr. Rahul Chowdhury, sir, to present the token of appreciation to our esteemed speaker, Dr. Sajal Chandra, sir, as a gesture of our gratitude.
Thank you. Thank you, everyone. On behalf of the organizing team, I would like to express our sincere gratitude to our respected speaker, Dr. Sajal Chandra Banik, sir. He's also a direct teacher of me at CUET. So thank you, sir, for delivering.
Thank you very much.
Thank you, sir, for delivering such an insightful and engaging session. Your valuable perspective on human-robot collaboration have truly enriched our understanding. I would like to thank all the participants for their active presence and the quiz winner also. And hope you are interested throughout the session. We hope this discussion inspire you to explore more in the evolving field. With that, I will like to formally conclude today's session, and thank you, everyone.
Thank you. Thank you very much.
Thank you, sir.
Thank you, sir, for this kind gesture. Now I would like to invite our IEEE Premier University Student Run Chairperson, Mr. Iftikhar Mohammad Saifuddin Chowdhury Bhaiya, to present the token of appreciation to our Spring Session Chair, Mr. Rahul Chowdhury, sir, as a gesture of our gratitude.
Am I audible?
Yeah, yes.
Yes.
Okay. I would like to thank Mr. Rahul Chowdhury, sir, for being our wonderful session chair in helping us facilitate this session. Thank you, sir. Here is a small token of appreciation from us. Please accept it.
Thank you. Thank you, Iftikhar. Thank you.
Thank you, sir.
Thank you for this kind gesture. So as we come to the end of today's session, it was truly have been a privilege to learn from Dr. Sajal Chandra Banik, sir. Sir, thank you for sharing your valuable time and knowledge with us. And we are also sincerely grateful to our session chair, Mr. Rahul Chowdhury, sir. And sir, also thank you for your continuous support and presence. So before we conclude, as a host, I would like to say once again, having Sajal sir here today was been a truly special for me. Because as Sajal sir student, I had privilege of learning mechanical engineering drawing from sir, and it was from sir that my passion for robotics began. So it is not just as a host, but also as your student that I feel truly honored and grateful to have you with us today. Thank you very much, sir.
Thank you. Thank you. Okay.
Thank you, everyone. Now we can conclude.
Now we will now extend the meeting briefly for some important announcements. Sir, if you don't have any prior commitment, we would be honored if you kindly stay with us.
Okay.
iConnect 2026, a historic milestone for us as a premier university, is going to host its first ever international conference, Shape the Future of Tech at iConnect 2026. So submit your research paper by June 15 to join this IEEE sponsor landmark event in Chattogram. For further updates, follow our pages provided in the chat box. The membership drive is ongoing. Join IEEE to unlock opportunities for networking, learning, and professional growth. We have been on campus ground floor from this week. We'll be extending the booth till Sunday. Make sure visit us, the registration booth, for further updates and follow our pages provided in the chat box. And I would like to once again remind you all kindly of the attendance form provided in the chat box and receive your session certificate. So we conclude here for tonight. Make sure to join us again for our fifth and final session of the IEEE Education Week series titled The New Energy Era, Transition Markets, Mandates and Modern Regulation, tomorrow at 8 p.m., where the keynote speaker will be Dr. Sheikh Anwarul Fatah, Sir, Professor, Department of IEEE, CUET. Also, as a chief guest, our Vice Chancellor, Professor S.M. Nusrul Kodi, Sir, will be present. Again, thank you once again, everyone. Assalamu alaikum warahmatullah. Goodbye. Allah Hafiz.
Goodbye.
Thank you, everyone.
I would like to request the participants, those who have not filled up the attendance form, kindly fill up the form from the chat box. We'll wait a few more minutes before closing the session. Kindly fill up the attendance form. Thank you. I hope all of you have filled out the attendance form. We are ending the session. Thank you everyone for joining. Kindly join us again for our final session tomorrow. Good night, everyone. Assalamu alaikum.